So let's see how we use Planner inside modeFRONTIER. You're looking at a modeFRONTIER GUI, and what you see here is an example of a modeFRONTIER workflow. In this case, it's a simple Excel-based model, and to this Excel-based model called heat exchanger model, we have connected 5 parameters as inputs. So these are the 5 parameters that modeFRONTIER can control and change via its algorithms. Similarly, on the output side, we have 2 results that we are interested in, and we're extracting those from Excel model. With these, this workflow is complete. For more details about how to create a workflow in modeFRONTIER, please refer to one of our other videos. Let's see how to use Planner now. So we have this workflow complete. Then if you see here at the top, there is a tab that's called Planner. So let's click on that one. In here, you will get to decide how to run that execution strategy, and that's defined by the plan. If you want to start quickly, there are some pre-made configurations available for you, and they are available in this choose scenario button. So if you click there, this will show you 6 options, 6 varieties that are pre-configured. So as the names say, first one is called single run. So this is typically useful if you have a newly created workflow and then you just want to test out all the processes and connections and that everything is working fine. So typically this is run with a default value, and then you get the results, and if they're expected results, then everything checks out. After that, you can move on to design of experiments. So this is a typical design of experiment strategy. With it, all the different algorithms are available for you to choose. Then optimization plan. This is where you will define objectives and constraints for your outputs, and then run it with optimization algorithms to find you best possible solutions for your problem. The last 3, they are about uncertainty quantification. So robust analysis, robust optimization, and reliability-based optimization. These 3 are under the limbs of uncertainty quantification, and we will be planning a separate video doing a deep dive into these shortly. So in this video, we will go through these 3 plans, the top 3 plans. So let's start with the single run plan. So as the name suggests, this plan is to verify and validate that your workflow and connections are working correctly, or in any other time if you just want to evaluate a run quickly or just one design configuration, this is the plan. So very minimal things for you to set here. So there are these 2 that are shown: input domain and output domain. So input domain, you can always go into this edit inputs and have a look at what parameters or what inputs are defined. So in this case, I have 5 parameters, and if I'm not running a DOE or any kind of a variation study on that, it's okay to set them as parameters. So next up is the output domain. In this case, we can just quickly see that there are 2 parameters, Q and DP, and they are both of the parameter type. Click OK there. And with these 2 modules, the setup is complete. If you want to add some additional properties which you'd like to control, such as run options, that can be added from there, and then we can quickly go over and see what the options are. So run options gives you control over how many concurrent designs to run and other things about controlling the run time. They also let you control unfeasible and error design treatment, and most importantly also lets you choose what to do with the files and logs that are generated during the run. So you can change all those properties from here and they will be stored in the plan. With all these things, the setup is complete, and then you're able to run this project. You can also overwrite the file and then it will start to run it. It takes us to this run area, which gives us the opportunity to monitor the run progress. If you are running multiple designs, you can see how long it's taking per design, and also if there are some failure designs, you are able to check all the logs associated and figure out why the designs are failing. Once that's done, you are also able to go to design space area. That's the last tab, and that tab allows you to visualize all the runs and also plot and make some charts on them to get some insights. We will be providing a separate video on design space. So with these things, this run is complete. We can see that there was 1 design completed because it was a single run, and it's green, meaning all the results are successfully extracted by modeFRONTIER. So let's go ahead with the next plan. It's called design of experiments. So for design of experiments, we get these 3 modules populated here: input domain, output domain, and DOE table. So let's take a look at the input domain again. So you'll see that the same 5 variables that we had earlier are listed again. This time the type is set to variable continuous. If you click here, you can see that there are some other options as well. So variable continuous, variable discrete ordered, and variable discrete unordered. So these two, discrete ordered and unordered, let you make the variable accept some steps instead of moving continuously within the domain. Constant, as the name suggests, is a constant value, so a DOE algorithm cannot directly control it. For any type of variable, whether it's continuous or discrete, lower bound and upper bound are important. If you don't like to use lower bound and upper bound definition, there is also an alternative pair that can be used, and it's called central value and delta value. So central value typically is the middle value and then plus minus the delta value, and that defines your design domain for that variable. So you can choose to use either lower bound upper bound pair, or you can choose to use central bound and delta value pair. Depending on which value you change, the other pair is also adjusted accordingly. Finally, base and step values. These two are currently grayed out because we have said that these are continuous variable types. Therefore, there is 0 base, 0 step. If it was a discrete variable, you will see step size being clearly mentioned and a base value, which is how many possibilities are there for that variable. They will be listed as base. So with that, the variable setup is complete. For output domain, again it's the same, that there are only 2 variables. This time instead of parameters, we've chosen them to make variable, and they are the same 2 variables as earlier. Lastly, there is one extra module which we didn't do earlier, and it's called DOE table. Because we want to run a design of experiment, we need to define the DOEs that we would like to run. So to do that, you are able to select from the tables that already exist, if they do exist in the project. Otherwise, you can add a new project or new table for this project, and it comes from this area. So if I click add, I am able to get a new table. I'm going to call it demo1 and then click OK. With that, in this empty table, I'm able to populate it with more designs, and those designs can be added either via this add designs button, and from there I can see the list of algorithms and I can choose one of these algorithms. Again, we will cover these in more detail in a separate video. For now, let's go ahead with the uniform Latin hypercube method, and then I'm going to add about 30 designs, and then with add button my table is populated. I can also add a baseline design, and modeFRONTIER creates this baseline design based on the default values defined for each variable. So see that baseline has been added, and this is taking on the same values as we saw earlier in the single run plan. So with this, the table is complete. So click OK. And with these 3 settings, which are bare minimum, this plan is good to go. Again, like before, you can add run options to control how these runs are done in terms of concurrent runs or file management options. And if there are no other settings that you wish to change, then click on the run project button. Now, because we have more than one plan, modeFRONTIER is asking us to confirm which plan that we like to run. And in this case, it's DOE plan, so that's good. We are also able to preview how that plan looks like. And if we are happy with all these settings, click OK and save this project, overwrite if needed, and that's good to go. Finally, let's take a look at optimization plan. So choose scenario, optimization. With optimization plan, we get these different modules. So first 2 modules are same as before, input domain and output domain. So input domain again can be same as previous study, or you can change the lower bound, upper bound, or any other properties if you want to do that. The nice thing about the planner environment is that each of the plans can maintain its own separate design domain. So in some of the plans, some variables can be constants, in some other ones they are moving, and then their bounds can also be different between different plans. So it's a nice flexibility. If you're happy with these bounds, then you can just click OK or cancel. Output domain is similar. You can just quickly preview how many variables. In this case there are 2, and that's good enough. The next one is objectives, and that's the most essential one for optimization plan. For you to be able to run any optimization, you need to have at least one objective. So in this case, we are going to populate that. In our problem, it's a heat exchanger. So we have 2 objectives. One is to minimize the pressure drop, and the other one is to maximize amount of heat exchanged between the 2 fluids. So I'd like to add one objective called min dp, and this one is on the output dp, and the type for this is minimize, lower the better. I'm going to add another one from this create button, and this will let me rename it, so I'll call it max q, and this one I need to set it on the output q, and its type is maximize because I'd like to increase, higher the better. With that, objectives are completely set up. In addition to this, if your problem also requires you to specify some constraints, you're able to do that by adding this extra module called constraints. Then if you also would like to take advantage of some of the previously done DOE tables as starting points, you are able to add a DOE table module in this one as well. If you would like to also use previously generated data in the form of session table, you can add session table module and then direct modeFRONTIER to run the new optimization and save the results in that chosen table. The advantage of that could be that the algorithm that you're using here can take advantage of the older data. So if they are smarter algorithms where they use previous data for response surface training or some kind of predictive exploration, they can use the previous data. So session table, using a session table as a starting point, it's a good strategy there. And most algorithms can also avoid rerunning the designs if they already exist in the tables. So if we happen to have some data already in a table, good idea to use that using this session table option. If you don't plan to do that and you want to start from scratch, you can just eliminate this and modeFRONTIER will directly create a new table for this specific run. Finally, the optimization algorithm. You can see that there is a big list of algorithms here. We will be creating a new video separately which will go over these different algorithms, giving you some background about all these algorithms, when to use and what do they do. But for most of our general purpose suggestions, PyLoft is a good algorithm to go with. It's a multi-strategy algorithm, and that's what has been populated for this plan as well by default. So it's self-initializing, meaning that it does not require for you to provide a separate design of experiment as a starting point, but it can generate that on its own. All you need to specify is how many number of evaluations you wish to perform. And with that, this algorithm is good to go. So with all these settings, this plan is complete, and then you can click on Run Project button. Like the DOE plan, you get to select the plan. You just get to verify that it's the correct plan, and then you can click on this OK button, and then modeFRONTIER can run this project from here on. So similar to previous 2 plans, as soon as you choose to run this plan, you are taken to this run area. Again, like before, you can monitor all the run progress, statistics, and troubleshooting information required can be accessed from here. And in the design space area, you get the opportunity to monitor all the designs, all the runs, and then plot any visualizations if required. For more on design space, check out our other video which does a deep dive on that topic. This video was about introduction to Planner, and this is the end of it. Thanks for watching.